language called C. Alright, so when you make a C project, usually the first things you want to write are include stdio.h. You need that if you want to, like, I don't know, print stuff, I guess. And int main, let's say printf hello. Now everyone has to end with semicolon. So I'm going to write make, give me a sec, make intro.c. Oh yeah, actually it's supposed to be make intro, so it's gonna make intro.c. And I have to write /intro. It's gonna print hello. There's an error over there, but we're gonna fix that later. So we can write make intro and /intro. Oh yeah, I'm also gonna write clear. So intro's already up to date, so it's gonna run intro over here. So I'm gonna have to write /n, which means new line if I want it to be proper. So anyways, so this int main, I mean we don't really have to learn what it is right now. It's just there for now. So anyways, printf stands for print format because yeah, we're gonna learn that later as usual. So let's print 3 lines. If we remove the \n out of one of them, that's gonna turn to this because there's no new line separating them. Okay, so now we're gonna learn about variables. There are 3 types. Also, you can use this to make these 2 slashes to make comments. Anyways, there are 2 types. I mean, there are some number of types of variables: int or number, string or piece of text, char or character, and float, which is an integer with decimals. There are other types which you're gonna learn about later. But these are the 4 main types. So let's make an int. Int number is equal to 5. That's the syntax to make a number. So if I want to include an integer, if you know another language, then you might just say hello int plus number, but that doesn't really work. But this is print format, not just prints. So we can write this weird thing. But the S there stands for string. So next argument. Oh yeah, I'm supposed to write I for integer. So next argument besides this is going to be the number itself. So yeah, it depends on the order. Like if I make another number which is 8, and I do another I, comma, number 2. That's how I'll find 8. Anyways, next type of variable is strings. So strings don't really exist in standard C. So we're going to include string.h to do this. The name is equal to Isa. It still doesn't work. Well, a string is just multiple characters. So char name, put these brackets here. Yeah, they're gonna learn about them later. Let's put represent the S for string, and I'm gonna put name. That's hello Isa. So now about characters themselves. Character, also, if you're using a string in C, it must be double quotes, but character must be single quotes. But well, it's in the name. A character is just a single character. Let me just modify this a bit. Okay. Then the other type is floats, which is a number that has decimals. You can write F for floats, write num, and bib, so that works. So yeah. Also, you can initialize variables like this. So let's say int num, and then you can write the value later. Num is equal to 5. Let's say this. So you could even put the int num over here. It's still going to work. So anyways, that'll be it for today's tutorials. If you enjoyed, please like and subscribe. So bye. Today we're going to learn about functions in C. Okay, so first let's include stdio.h, and then we're gonna write int main. Let's just write printf hello world for some reason. Okay, so now let's run it. Make func real and /func real. So it runs it and says hello world. Let me just have the /n here so I can create a new line. Okay, it works. So instead of if I want to write print hello world many times, well, we could just use a loop, but we could turn the print hello world into a function. So to create a function, write void, and then the name of the function. So let's call it hello. And then we're gonna discuss what these brackets are for later. Then we use this for the contents of the function. Here I'm gonna put printf hello world. So now instead of writing printf hello world 3 times, we can just write hello 3 times. Hello world, hello world, hello world. So it still does the same thing, except that it's more concise. Anyways, you can also put functions on the bottom, but it's not really gonna work. You have to declare the function here. So void hello, and so now it works. Okay, so let's just put it back to the top. So functions can have these things called arguments. So that's what those brackets are for. So let's say hello name. So string name. I'm going to include string.h for this. Anyway, so now char name. This char, whatever this is, it means string. Basically, a string is many characters. So yeah. Oh yeah, it's supposed to be like this. Anyways, I'm gonna say print hello. Here I'm gonna put S for string. And here I'm gonna put name over here. So if I write hello, or write something there, it's gonna work. So we can have multiple arguments. So let's say we have a function called add. It's gonna have int num1, comma int num2. So we'll say int sum is equal to num1 plus num2, and yeah. So we'll say printf sum. Okay, I'm gonna use this integer thing over here, comma sum. I'm gonna add /n as well. So here, if I write sum 5, 10, and I run it, oh yeah, this is supposed to be add 5, 10. So now we're gonna end up with the answer 15. So anyways, but instead of having it print the value, what if you want to do more operations on the value? Like if you want to add the sum of something, that won't be possible since all add does is print it. It doesn't actually return any value. So we can do this. We can fix this with return. So return sum instead of printing sum. We're gonna say int n is equal to add 5, 10. This is and here we're gonna put printf. I'm gonna use the integer thing here. It's gonna print n. So yeah, because the return value is an integer. So instead of writing void over here, we're supposed to change it to int. So because it returns an integer. That's why this thing is int main. It returns integers. Like if we put, give me something just about slash n here, so that the program works. If we put a return 0 in the middle of here, it's gonna terminate the program. If we try to return characters or something, well, it's still gonna terminate the program. But I mean, it's just meant to return integers placed in the function. So yeah. Anyways, so now let's combine this with for loops. For int I is equal to 0. For I is less than let's say 10, and I plus plus, and int sum is equal to add I comma I times I. And so now we're just gonna copy this print function. So int sum over here. 0, 2, 6, 12, 20, 30, 42, 56, 72, 90. Alright, so let's make a square function. Int square. Int num. I'm gonna say int sq is equal to num times num. Return sq. So instead of writing r times I, we can just use square I. Now if we run it, it's still gonna return the same thing. But yeah, instead of using slash n, let's just put a space over here. And then after it finishes, I'm gonna print the slash n. Anyways, so that's the end of today's tutorial. If you enjoyed, leave a like and subscribe. So bye. Hi guys, I am Isa, and today we're talking about loops and if statements in C. Alright, so include stdio.h and int main printf hello world. So now we just run it by writing make loopers and dot slash loopers. Oh, give me just write slash n here. So now it works. So yeah. So first are if statements. So let's say int variable is equal to 4. So I'm going to say if variable is equal to 4, then printf it is 4. So here it says it is 4. We also write this exclamation mark equals to mean not equals. So it says nothing because well it does not for. You can use greater than or less than, greater than or equal to, or less than or equal to, those stuff. Anyways, so besides if, there are also else statements. So let's say if the variable is 4, it's gonna say it's 4. Else, so else if the variable is greater than 4, then it's gonna print f it is greater than 4. So now, since the variable is 4, it's gonna say it's 4. If I make it 7, it's gonna say it's greater than 4. If I write 2, it's gonna say nothing. So I'm going to write else. Because if the variable is 4 is not greater than 4, that means it must be less than 4. So here, I'm going to write printf, it is less than 4. So now here it is again. Then I'm going to say it's less than 4. So yeah, that's how if statements work. The next things are loops. So, the first one we're going to learn are for loops. So, this is their syntax. For int r equal to 0. R is less than. Let's just make a variable called t. Maybe t will be 10. So r dot in t, I plus plus. I plus plus means I will keep increasing by 1 every step. So the printf hello. So for the product, it's gonna print hello 10 times. So yeah, anyways. If I remove the slash n, if I remove the backslash n, then it's just gonna do it like that. If I wanted to print like a grid of hellos for some reason, I could just copy the for loop, paste it in here. And for int j is equal to 0, j is less than. I'm gonna make a new variable called u, which will be 8. J is less than u, j plus plus, printf, a hashtag. If I do that, it's just gonna print many hashtags without, any line breaks. So here, where I printf slash n, just gonna print a blank new line after all that. So now this t is basically the height. Yeah, the t is basically the height, and the u is the width. You can make the same thing using while loops. So I'm gonna say proper this. We're gonna need 2 more variables. Let me make v is equal to 0 and w is also equal to 0. So while v is less than t, so I'm gonna write v plus plus to increase the value of v. I'm gonna print hashtag. So if I run it, I'll print f. So it's gonna print that 3 times. Okay, yeah, this is supposed to be u. Oh, w is less than u, w plus plus, yeah, all that stuff. So it's gonna print whatever number, those things. Anyways, so now let's say while v is less than t, I'm gonna put the brackets. I'm gonna copy this printf thing to here. So here I'm just gonna printf backslash n. Here v plus plus. It just does this. The reason why is because you have to set v to 0. So now it works. except that the roles are swapped. So let me just change it. T10, U3. So now it's going to work. Anyways, that's the end of today's tutorial. If you enjoyed, leave a like and subscribe. So bye. Hi guys, I am Isa. And today we're going to learn about arrays and switch statements in C. Alright, so I'm going to include stdio.h. So now I'm going to just create the main function. Alright, so to create an array, you have to write ints, or let me just write int numbers, and then after the variable name, you have to put these two brackets. What you put in the brackets, well, we're going to discuss that later. So we can make it a list. Let's say 8, 9, 1000. Alright, so now we have our list. So now the list, it has to be using curly braces like this. So yeah. Anyways, so if I want to access a certain, element of the numbers, then you can use this notation. Print f. So let's make it to be an integer. So then comma numbers. Then I have to put the number. It starts at 0 for some odd reason. So now let's run it. It prints out 8. 8 is the first number. So now if I write 1, it's going to print this element. 9, if I write 2, it's going to print that element, 2000, yeah, so on. Anyways, so what are these brackets really, like for? Well, the brackets are for specifying a certain length for the array. So, we're going to dive into this out later as usual. So let me just combine this with loading while loops, actually for loops. Int I is equal to 0. I is less than, the length of numbers is, 5. How about I plus plus. So, let's see, printf I slash n, comma, numbers, bracket I. Sounds good. Print has all the numbers. Let me just make it more stylish. So I'm gonna print comma, and then after all that, I'm gonna print slash n. I mean backslash n. So now let me just write printf. The numbers are 8, 9, 2050, 800. There's a comma here. I mean, well, this really matters anyways. So yeah, as I said, this bracket is for defining the lengths. If I write 4, it's gonna show an error. There are too many elements. If I write 10, still gonna show an error because there are too little elements. Oh wait, actually, if you write 10, it can work. The rest of the elements will basically just be 0. So like if I write I is less than 10, everything else is 0. But if I write a number that's less than what it's actually, then it's gonna show some weird stuff. They're just garbage values. We're gonna look at them in the future. But yeah, they're not really. They sort of just look like random numbers. Anyways, so yeah. The next thing we have to worry about in this tutorial are switch statements. So let's just I don't know, make a new file. Let me just copy this normal code. Fake switchers and dot slash. Alright, so let's say int num is equal to 5. Let's make a switch statement. Oh wait, actually I'll say int day is equal to 5. I'll make that example. So let's use a switch statement. we're gonna say switch day because, well, yeah. Let's say case 1, printf, Monday. Now I'm going to put a slash n. So now, if I normally run it, it's going to say nothing. If the date is 1, so like, if you have a lot of ifs instead of actually writing all those ifs, you can just use switch statements because they'll be more efficient. Today, we're going to learn about struct and enums in C. Okay, so now we just set up our basic C program. So anyways, structs. If you know another language, there's also like classes, so like custom data structures. Okay, so type def struct. So yeah, then you put brackets. Then here you write the name. So let's call it person. So we have to write the values in here. So int name, int age, and yeah, like the normal stuff. So anyways, I'm gonna put person purse is equal to, and say so let's just say person purse. And okay, so a purse dot name is equal to purse, and purse dot age is equal to this number. So let's print an integer. So what is this integer? It's gonna be purse dot age. So now if we run it, it's gonna write this number. Okay, so yeah, this says int name. It's supposed to be char name because, well, that's the way to represent strings anyways, so yeah. So now let's run it. Okay, whatever. So yeah, so now let's print a character, and that character is gonna be post.name. Let me just change this. Now print it. So yeah, let me also add a slash n, backslash n. So now it prints the age and the name. So anyways, yeah, that's basically how to use structs. So the next one we're going to learn about is our enums. So to create an enum, let me just to create an enum. Here we need to write enum. Let's call it level. So we're gonna write low, comma medium, comma high. So an enum is like a list of constants. Yeah, also it's recommended to use capital letters, but it's not necessary. We recommend it because well, they're constants. Constants usually use capital letters. Oh yeah, speaking of constants, you can make a variable constant by writing constant for it. Then we'll be able to change. So anyways, about the enums, I'm gonna say enum level. Let's call the variable enum, and then we'll set it to low. Now printf, let's say D for well, I don't know, maybe data. And we're gonna enum, and then we're just gonna put a semicolon, and so now it should be 0. So low is 0 here. Let's use medium. Medium is 1, and you probably know by now high will be 2. Those are the default values for enums. But if you want, you could change those values. So instead of low being 0, you can write low is equal to 50. So now if we're into low is gonna equal to 50. Let me just change it. I'm saying is equal to 0. Low 25, medium 50, high 75, and all 100. Oh yeah, you can put a comma here if you want, but well, let's just not do that because it's more elegant. Print all, print 100. So yeah, anyway, that's gonna be today's tutorial. If you enjoyed, leave a like and subscribe. So bye. Isa. And today we're going to learn about libraries in C. So let's say we have this file and want to import like another file. We could do this. Let's select it as stdio.h. It's actually another file stored on my computer. So let me just open it up. This is the full stdio.h file. I mean, that's pretty long and stuff. But yeah, even this includes stdio.h. This includes stdio.h file. It includes other files. These other files link to other files. And those other files don't link to other files, but yeah. So anyways, so let's say in this file I have a certain function. Do a void because it doesn't have any return value. Void hello, and we're gonna say printf hello. So now for the import it, we're gonna have to the include function. You might think, oh, you have to use these brackets, like the same way you do in the D. But it doesn't actually work because for these angle brackets, it's only going to choose files that are in a certain place. This library is not in a certain place, so I have to use these normal things. Anyways, now we can call the function that was there, and it's going to work. So let's try functions with arguments. Oh yeah, so it's also a return value. So int add. Why not rename this file to math.h because why not? So int add int a comma int b. So let's say int r is equal to a plus b, and I'm gonna print out the results. So, I'm gonna return the results. Return r. Gonna add int subtract, multiply, divide. So on the subtract, just gonna change what this one sign. Multiply, do the same thing, and is it for divide? So then this other file, I'm gonna say int o is equal to int p is equal to 5, int q is equal to 8, int r is equal to add p comma q Let's say print f. It's gonna be an integer. It's gonna be r. So now let's try it out. Oh yeah, I named the file to math.h. So now it says 13. Now that should work. Let's add another integer. Int s is equal to subtract pq. Now just print s. -3. Let's say int t is equal to multiply pq. So int u is equal to divide p by q. So now I'm going to say int v is equal to r plus s plus c plus u. It's now I'm going to print v and shows this. Oh yeah, semicolon. Shows this result, which just so happens to be 50. So anyways, that's the end of today's tutorial. If you enjoyed, please like and subscribe. So bye. Hi guys, I am Isa, and today we're going to learn about memory management in C. Okay, so first I'm going to have to include stdio as always. And then I'm going to make int main, and I'm going to put the printf something. So now let me find out my project's gonna do this dog. Anyways, here we're going to learn about memory. So let's say we have a variable. So int v is equal to 5. So we can print integer. We can use the size of command to find the size of v. So yeah, it's supposed to be lu, unsigned long. A log is basically like a float that can handle more numbers. But yeah, 4. 4 is the size of this. 4 is the size of every integer. So let's say if we do this extremely big number, you can see this error, which shows that this is the limit of integers. That's the limit of 4 bytes. So yeah, if we wanna add integers that are bigger than that, we can use long. Long stores 8 bytes, in which its limit is much bigger. But yeah, it still has a limit. Like for example, this number can be represented by log. Integer list was too large to be represented in any integer type. So if you want to do something like this, we're gonna have to split it up into 2. So yeah. So this thing is stored in like 4 bytes in memory. What if we want to allocate memory ourselves? Now there are 2 commands we can use. This function which only has one parameter, size, and this function which has a number and size. We can proceed to allocate memory. So let's say we have int O1 and int O2. So you want to allocate the memory to, like them. So here I can say that O1 is equal to MALLC or whatever. And put the size. The size should be 4 because that's the default for an integer. And O2 should be the same thing. Now let's run it. We're going to have to put these asterisks besides the thing. So yeah, for this you need to include stdlib.h. So now it's done what it needs to do. If you even change it to 5, and it's still going to work. So that means the O1 limit will be bigger than the one for O2. But yeah, O1 and O2 are locations in the memory. So, well, yeah, that's that. But yeah, so we can just use the call OC function. What says? So we only have one variable here, so we're just gonna use the one sig. But yeah, we don't have one, so there was a one. So let's say you want to reallocate memory, like the memory you put is not enough. So let's use the same example with O1 and O2. So O2 goes to the realloc function, which reallocates memory and stuff. So you have to write the size and then where I put it. So 5 O2. Now let's run it. Okay, this will be O1. So yeah, you can see this. We're gonna change the size here. So now, this amount of memory has been reallocated to O1. Allocate memory. So let's say this O1 is a chunk of memory. You want to deallocate it. We can use the free function. To let that memory free or whatever. So yeah, memory will be freed. So yeah. Anyways, in order to see, you have to make sure that you manage your memory properly, or else, well, things like crashes and the bad stuff will happen. So that's what we're going to talk about. These are called memory leaks. So let's say int q is equal to 5. We're going to have a pointer here. Let's say int, let's call it ptr for pointer, So I'm going to say ptr is equal to call oc, and they're going to say like maybe 100 bytes. Well, yeah, so it's going to be mol oc 100 bytes, 100 whole of that stuff. Yeah, it doesn't do 1,000, I can even do that many. But I'll just leave it at 100 or just 10. Anyways, so if I make ptr to point at x, so I can do that with this symbol. Okay, I'm gonna make it to point at q, and the memory here, it's going to be inaccessible. It's basically wasting. If too much is wasted, then it's gonna make your computer to crash and stuff. But yeah, the good thing is to freeze the memory, so free PTR. Then all the problems will be solved. So anyway, that's the end of today's tutorial. If you enjoyed, leave a like and subscribe. So bye. Alright, so let's say we have a variable. So int o is equal to whatever. Say int o is equal to 5. So now we could print. We're gonna say I comma int. I comma o. So now let's run our project. So now print the integer one, which is 5. But we could create a pointer variable. So let's write this thing here. So let's call it PTR. I'm gonna set equal to this thing. So that thing basically allows us to, point to O. So now basically allows us to point to O. And it basically allows us to see like where in the memory O even is. So let's print PTR. So you're gonna have to write P over here. So it's gonna print out its location in memory. Now I'm gonna like this. And print this weird number. So if I have another integer, P, let's make it to be 8. So now let's have another integer, PTR2. It's gonna be basic for P. So here if I write PTR2, and I run this. It's gonna show BTR2's adjusting the memory, which I mean is it's different. So now let's say I change BTR. If I change the value, the memory just won't change. So let's say I change P to long, and memory adjust going to change. Memory adjust is going to change a little bit because, well, duh, it's a different data type. So we can see this in action. That's what's an I. Next I will be size of P. So yeah, it's supposed to be LU, long unsigned or whatever. So now it's gonna say 8. So P is 8. So O, an integer, has to be 4. So that's why they have to be different locations in memory, because duh, so different sizes. Right, so the next thing is to, you know, so let's say we just have a normal pointer, and then if I repeat or oh yeah, I didn't mention this earlier, but a pointer is its definition is a variable storing the memory address of something. So anyways, so back to my cool example. So you can see that if we use this asterisk thing, it's gonna show the value 0x9. It's always 9. So yeah, also pointers can be formatted 2 ways, either this way or this way. But I mean, yeah, it can be any way you want. So yeah. Anyways, the next thing is how we can use pointers with arrays. So also you have pointer. Let's say O is an array. So let's just say, oh yeah, before we get to the array example, we can do pointer arithmetic. So let's say in PT O is equal to PTR plus 1. So now let's print PT O, and it's gonna show that thing. Now if we print PTR, it's gonna show, well, that, oh yeah, I have to remove this from PTR, PTO. It's not just this P, and now go back to PTO, and now we will see both of them side by side. As you can see, they're the same things. Yeah, they're almost the same things, at least. Just a couple numbers are changed, numbers here are changed. But, I mean, yeah, they're like almost the same. So let's say PTR plus 10 or something. Then we're gonna get a bigger one, or yeah, it seems to be bigger, whatever. So yeah, anyways, back to the arrays thing. Let's say it's ARR is an array. So it's ARR is an array. It's gonna consist of 5, 9, 2, 4, and 10. Right, so I'm gonna run through all the elements. There's a for loop. For and R is equal to 0. R is less than 2, 3, 4, 5. Well, wasn't like 5. R plus plus. So I'm gonna put these brackets over here. Okay, so now I'm gonna print f. So I'm gonna print out where. So now let's run it. We have that semicolon here. So now let's run it. It's gonna print all the elements. We'll just add a space bar. So if I print the pointers, you know, the memory just about the elements, then it's gonna say all these. As you can see, they're basically the same thing. But you might notice something. You know that the size of an int is 4. So the size of an int is 4. Oh, this. The other way is 80. And here, it does 84. 80 plus 4, then 88, then 92, then 96. Keeps adding 4 every time for each of the elements. Let's say it's a long. Longs have 8. So now that we run it, it's gonna say basically the same thing. But it's gonna keep adding 8 instead of adding whatever. So you can see there's an 8 difference. Anyways, back to integers. So, if you go write a pointer, so I'm gonna write int ptr is equal to memory address of array 0, 0 elements. So I'm gonna print I print the pointer right here. So I'm gonna print ptr. It's gonna say this. So now let's just change this to asterisk ptr. It's gonna tell us what the value is 5. But let's say let's call this underscore ptr now. So now let's say so real ptr is equal to underscore ptr plus 1. What's that gonna do? Well, obviously it's gonna do nothing because okay, actually never mind. It changes to the next value, which is 9. So if we add 2, for example, it's going to say 2 because 2 is the third element. If we add 4, it's going to say A. A is 10 hexadecimal. The hexadecimal we're doing here. So if we say plus 5 though, then well, it's going to say 0 because well, the third nothing there. But then if we go after 5, well yeah, also so I notice every array ends with this 0. You can actually see it, but after this 10, it's actually a 0. It's always there. Anyways, if you go after 5, you're going to start seeing these weird numbers, which, I mean, yeah, we're going to talk about them in another tutorial. Speaking of the tutorial, that's the end of today's tutorial. If you enjoyed, like and subscribe. So, bye.